Alright guys, so this is section 3.4. I'm sorry that we have to do a video lecture for it, but I feel like it's better than you not getting the information at all. Section 3.4 should be a pretty easy section. It's called Library of Functions and Circles. So there's all these basic functions that you need to know. You need to know what a constant function looks like. I've listed all of these out in your notes. So a constant function looks like this, f of x equals b. Now b just represents a number. Okay. So it could be like f of x equals 4, or f of x equals -3, whatever. It's just f of x equals a number, and it's a horizontal line through that number. So you can see a picture of the graph here. Okay. Another function that you need to know and be familiar with is the identity function. The identity function is f of x equals x. Okay, so it's just a line. If you think about it, remember y equals mx plus b. So this is f of x equals mx plus b with a slope of 1 and a y-intercept of 0. That's where we get f of x equals x. So it's just this line right here. Okay, you've got the point -1, -1, 0, 0, and 1, 1. Now I know that may be difficult to see on the video, but it's all on your paper, all typed out for you. Okay, the next one that you need to know is the square function, f of x equals x squared. That creates a parabola. Okay. And this point down here, the 0, 0, that's the vertex of the parabola. You do need to know that. Okay, and these are some key points that are on this function. 1, 1, 2, 4, -2, 4, -1, 1. Okay, you also need to know a cube function, which looks like this. And the key points that are on that cube function. You need to know the square root function. Okay, square root function is f of x equals the square root of x. Looks like this. Notice that there are no negative values on that function. Everything is positive. That's because you can't plug in a negative to a square root. You know this. So we start at 0, 0. Another key point is 1, 1. And then we have the point 4, 2. Let's see, third to last function you need to know is the cube root function. F of x equals the cube root of x. Looks like this. And I have several key points on there for you to know. Now, one thing I do want to tell you is all of these functions that you're doing, so these two right here and then all the ones we did a minute ago, you will have some very basic questions in this homework that simply give you a picture and you have to say, oh, this is the cube function or the square function or the cube root function or the identity function. So you're basically just matching the name to the picture or the graph, I should say, in these easy questions. So those should be some really easy homework questions you can just reference this table for. Okay, the reciprocal function is f of x equals 1 over x, and it looks like this. Has a piece going this way and a piece going this way. Okay, and the absolute value function looks like a v, and the original absolute value of x is centered at 0, 0. And again, I have several key points for you to know about that absolute value function. So there's all your functions, library of functions you need to have memorized. Like I said, you'll have several that are just matching. You really do need to know that the constant function looks like this, the identity function looks like this, the square function looks like this, and so forth, because there will actually be questions on your test where they just give you a picture and you have to identify it. You know, they'll give you a picture that looks like this. And that's all that'll be on the picture. And you have to say, oh, that's the square function. You have to know the name of it. Okay, so make sure that you memorize this table of functions. Let me know if you have any questions about that. So we're going to go on to some of your more difficult homework problems in just a second, but we do need to talk about this first. So this is about symmetry. Okay, all of these are about symmetry. A graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x negative y is also on the graph. So it's symmetric with respect to the x-axis if it looks like this. That's your x and y, okay? Your x-axis and your y-axis. So let's say this is the original function. Do you see how this function can be folded over the x-axis? That's why it's symmetric with respect to the x-axis. You can literally take that blue function and fold it over the x-axis. Therefore, it's symmetric with respect to the x-axis. All right, let's fill in the next one. It says a graph is said to be symmetric with respect to the y-axis if for every point xy on the graph, the point negative xy is also on the graph. So they say a picture is worth 1,000 words. I feel like that's true here. It's easier to see what y symmetry looks like with a picture. So this is my y-axis and my x-axis. So remember, symmetric with respect to the x-axis meant you could fold it over the x-axis. So symmetric with respect to the y-axis means that you can fold it over the y-axis. So if you had something like this, and it was identical on the other side of the y-axis, that would be symmetric with respect to the y-axis. So it's very simple. If you can fold it over the x-axis, it's symmetric with respect to the x-axis. If you can fold it over the y-axis, it's symmetric with respect to the y-axis. So let's do the last one. It says a graph is said to be symmetric with respect to the origin if for every point xy on the graph, the point negative x negative y is also on the graph. Okay, so symmetric with respect to the origin has two steps. The first step is a y reflection. So y-axis reflection followed by an x-axis reflection. Or you can think of it as a 180-degree revolution about the origin. So I really shouldn't have called these steps. I should have said it's really one or the other. It's not step one or step two. You can think about it way one or way two. So I should have maybe said two ways to think about it rather than two steps. Okay, so again, picture's worth 1,000 words. So let me give you a picture of what symmetry to the origin would look like. This is the y-axis and this is the x-axis. So if you had something like this, and you can see it was rotated 180 degrees, okay, or you could think reflected over the y-axis, then reflected over the x-axis. Either way, this is what symmetry to the origin looks like, and these are the two ways you can think about it. So we have symmetry with respect to the x-axis, symmetry with respect to the y-axis, and symmetry with respect to the origin. And just so you know, I know this is a video lecture, but as always, if you have any questions as I'm going through the lecture, just star it and shoot me an email. I'd be glad to explain anything to you in further detail. Okay, so let's look at some practice problems. So we're going to look at example 1. It says list the intercepts of the equation y equals 3x cubed minus 81. Well, I taught you how to do intercepts when I taught you lesson 3.1, I believe, or 2.3, either 2.3 or 3.1. It's in those notes. But to find the intercepts of this equation, you have the x-intercepts and the y-intercepts. Okay. To find the x-intercepts, you let y be 0. And to find the y-intercepts, you let x be 0. So if y is 0, then I have 0 equals 3x cubed minus 81. And I just solve for x. Add 81 to both sides. 81 equals 3x cubed. Divide both sides by 3. Let's see, x cubed equals 27, and then I take the cube root of both sides, and it's an odd root, so I don't need to do plus or minus, and the cubed root of 27 is 3, so I get x equals 3, and the actual intercept is 3, 0. That comes from an x value of 3 and a y value of 0. So I found my x-intercept. It is 3, 0. So now I'm going to find my y-intercept by letting x be 0. So y equals 3 times 0 cubed minus 81. Well, 3 times 0 cubed is just 0. So I have 0 minus 81. So y is just negative 81. Okay, so that's an x value of 0 and a y value of negative 81. So my second answer, my y-intercept, is 0, negative 81. So these are my two answers. Okay, moving on to the next problem. It says, the function f of x equals the absolute value of x is decreasing on what interval? Okay, well, we learned about decreasing in 3.2, 3.3, okay, in that set of notes. But this is the absolute value function, and it was in one of our, or it was one of the ones in our table. I think it was the very last one. Let's see. Okay, so here's the absolute value function, and they asked us where it's decreasing. Well, decreasing means that it's sloping down. So it's decreasing right here. I'm going to highlight in green where it's decreasing. So it's decreasing from negative infinity to 0. So I'm going to say that our function, absolute value function, is decreasing from negative infinity to 0. Okay, this is the answer you would put in the computer. So you figure out where a function is increasing and decreasing simply by looking at its graph. Okay, it's sloping downward from negative infinity to 0, therefore it's decreasing from negative infinity to 0. Number 3, of the graphs given in the table above, so that huge table of functions for you to memorize, that's what it's referring to. Of the graphs given in the table above, which ones are symmetric with respect to the x-axis? Well, we talked about symmetry here. I'm sorry, it says symmetric with respect to the y-axis. Which ones are symmetric with respect to the y-axis? Well, we talked about symmetry here. We learned right here in this middle bullet point that if a graph is symmetric with respect to the y-axis, then we can fold it over the y. So I'm going to go through and look at these functions and see which one I can fold over y. I can fold that one over y, and it would be even. So the constant function, okay, so I'm going to go put that answer down. F of x equals b. The constant function can definitely be folded over the y-axis. Now I'm going to go back up and look again. Let's see. This one can't be folded over the y-axis. It wouldn't match up on both sides. The square function would. The square function would match up on both sides if I folded it over the y-axis for sure. So the square function is symmetric with respect to the y-axis. So I'm going to go down here and write f of x equals x squared. Okay. Cube function would not match up if you folded it over the y-axis. Square root function wouldn't match up if you folded over y-axis, neither would cube root. This one definitely wouldn't, but I think absolute value would. Absolute value would match up if you folded it over the y-axis, over this axis right here. So we'll make absolute value function our last answer. F of x equals the absolute value of x. Okay. Continuing. We're going to start talking about circles. This is the second part of this lesson. So a circle is the set of all points in a plane that are the same distance from a fixed point. Okay, that kind of makes sense, right? Because if you have a fixed point, your center point, a circle is all the points that are equally distant from that center point. We're going to pretend that's a little more equal, but you get the point. Okay. The distance from the center of a circle to any point on the circle is called the radius. So if you go from the center of the circle to any point on the circle, that's called the radius. The distance from one side of the circle to the opposite side of the circle, passing through the center, is called the diameter. So if you go from one side of the circle to the other side of the circle and you pass through the center point, that is called the diameter. So a diameter is made up of two radii, back to back. All right, that's just some basic vocabulary on circles. So this is very important. The equation of a circle with center 0, 0 is x squared plus y squared equals r squared. You have to know that formula for your test. You have to have it memorized. R is the radius. To graph the circle, you plot the center, so the center point, and another point r units away from the center point. Okay. So it's very important that you have this equation memorized. But this is also the process for how to graph a circle. So it's very important that you have that memorized as well. Okay, so you may get a question like this. Graph x squared plus y squared equals 4. State the center and the radius. So remember, the equation was x squared plus y squared equals r squared. So I'm going to rewrite this as x squared plus y squared equals 2 squared, because 4 is the same thing as 2 squared. So the center is 0, 0, and the radius is 2. And you might say, well, how do you know that the center is 0, 0? Well, let's go back and look at this definition right here. It says the equation of a circle with center 0, 0 looks like this. So if your equation looks like this, then the center is 0, 0. So they asked me to state the center and the radius. That's what I did right here. And now I'm going to graph it. Now graphing it's really easy. They're going to give you a y-axis and an x-axis, of course. Okay, so make sure you're drawing this. This is the x-axis and this is the y-axis. So like I said right here, in the second bullet point, it says to graph a circle, plot the center point. So that's what I'm going to do. The center point is 0, 0, so I'm going to plot 0, 0. And then it says plot another point r units from the center point. So you're just going to count out 2 units. 2 units. 2 units up, 2 units left, 2 units right, 2 units down. Okay, so you just do 2 units all ways and draw a circle through those outer 4 points. So when you graph it on paper, you actually need to graph 4 extra points. 1, 2, 3, 4. 1 up, 1 down, 1 left, 1 right. However, in Pearson, they're only going to make you graph 1 extra point. So in Pearson, you'll graph your center point, and then you can graph any one of these. You can graph the top one, the bottom one, the one on the left, or the one on the right. It doesn't matter. And Pearson will draw that circle for you. Okay, so these are your two answers. So let's do another one. It says graph 4x squared plus 4y squared equals 144. 4x squared plus 4y squared equals 144. Well, I have a problem because this equation right here, well, it doesn't look like this. It doesn't have x squared plus y squared by itself. So when you get to this problem, what you need to do is divide everything by 4, or whatever number is attached to x squared and y squared, so that your equation is in the right form. So the 4 cancels here and here. So we have x squared plus y squared. And 144 divided by 4 is 36. Okay, now that looks like my equation. My equation is x squared plus y squared equals r squared. So the radius must be 6. Because what squared gives you 36? 6. So I'm going to rewrite it as x squared plus y squared equals 6 squared. So now I'm ready to state my center and my radius. My center is 0, 0, and my radius is 6. That's my first answer. Now my second answer is to graph it. So I know I have to have my x and y axis, x axis. I know that I graph the center point, which is 0, 0. And then I'm going to count up 6, right 6, down 6, left 6. And draw a circle through those outer points. Now remember, on Pearson, you don't need all 4 of these outer points. You only need one of them. So just graph this center and then graph any of the others that you want. Just one. Pearson will graph that circle for you. All right, any questions? You can't ask questions. Just kidding. I'm so used to saying that. Okay, if you have questions, of course, just email me. All right, number 6. Write the equation of a circle with center 0, 0 and radius 9. Well, I know from the definition that the equation of a circle looks like this. So I'm just going to put the 9 in for the radius. So my answer is going to be x squared plus y squared equals 81. Okay, 9 squared is 81. So that's what you put in the computer. That's it. All right, let's do one more like it. Write the equation of the circle with center 0, 0 and radius square root of 7. So again, I have x squared plus y squared equals r squared. So in the place of r, I'm going to put the square root of 7. So I have x squared plus y squared equals the square root of 7 squared. Now here's where my prior algebra knowledge comes in. The square and the square root cancel each other out. Those are opposite operations, and opposite operations always cancel each other out. So that's going to be x squared plus y squared equals 7. And that is my final answer. All right, 2 more questions, guys, and we're finished with this lesson. So number 8 says, find an equation of the circle having the given center that passes through the given point. The center is 0, 0, and the point is negative 3, 5. So this is where it gets a little tough. You're going to have to pay close attention. So the way we're going to find this is by graphing. So first you're going to draw your x and y axis. This is my y-axis, this is my x-axis. Now the first point that you're going to plot is the center point. So I'm going to plot 0, 0. And I'm going to put some tick marks on here. And you should put some on yours as well. Because this graph needs to be a little more exact than the others. And this one, unlike the previous problems where we graphed, you're not actually going to put this one in the computer. This is a graph solely for your paper so that you can get to the correct answer. The other graphs will be done in the computer, but this one will not. This is just a means to get to the answer. So we draw our graph, we put some tick marks on it, and the first thing we do is plot that center point at 0, 0. Okay. Now we're going to plot the other point, negative 3, 5. So I'm going to count over negative 3 and up 1, 2, 3, 4, 5. Okay, so negative 3, 5 is going to be here. So this point is 0, 0. And this point is negative 3, 5. So you plot your 2 points, and then you're going to draw a triangle. So we draw our little right triangle, and I know that this length is 3 and that this length is 5. This is a height of 5 and a base of 3. So the question we have to ask ourselves is, how can we find this? Because this distance right here, well, that's the radius of our circle. We drew a triangle, but this slanted distance right here is the radius of our circle, guys. It said that the center of the circle was 0, 0, and that negative 3, 5 was a point on the circle. Well, that means that the circle looks like this. Okay? So this little distance is the radius of the circle. Well, they're asking me to find the equation of the circle. The only thing that I need for the equation is the radius. If I can find this length right here, then I can find the radius, or then I can find the equation. So in a right triangle, what can I use to find the hypotenuse? Pythagorean theorem. Pythagorean theorem is used for right triangles. Remember, this is A, B, and C. And it's A squared plus B squared equals C squared. So I'm going to say 5 squared plus 3 squared equals R squared. We're going to call this R because it's the radius of my circle. So that's 25 plus 9 equals R squared, which is 34 equals R squared. So we take the square root of both sides, and we get R equals the square root of 34. Now listen, this is your radius. Don't try to reduce it, okay? Now I don't think 34 reduces, but you know how if you had like the square root of 20 or something, that would break down into 4 times 5, which would be 2 square root of 5. I don't want you to try to do that. Don't try to break it down. It's unnecessary and it's just extra. So you found your radius, but the actual answer is the equation of the circle. Well, the equation of the circle is x squared plus y squared equals r squared. So that would be x squared plus y squared equals the square root of 34 squared. And we were reminded just a second ago that the square root and the square cancel each other off. So we have, as a final answer, x squared plus y squared equals 34. Now, I'm going to do another problem. Number 9 is exactly like this. It's just a new problem. But you may want to pause the video here and go back and look over this, because all of the previous problems were fairly easy, very few steps, you can obtain the answer quickly. But this one, not so much. There's quite a few steps. You have to graph the 2 points, draw a triangle, do Pythagorean theorem, that's your radius. Then you have to plug the radius into the equation formula. So take a second to look over it and make sure that you understand. Rework it if you need to, and then go on to number 9. All right, so here's number 9, last problem in this lesson. Find an equation of the circle having the given center that passes through the given point. So we're going to do the same thing. The center is 0, 0. The point is 1235. So I'm going to draw my graph. Okay, so I'm going to do my y-axis by 5s. Okay, so each tick mark represents a 5. 10, 15, 20, 25, 30, 35, 40, 45, and so forth. Okay, and I'm going to do my x-axis by 2s. And if you're like, well, how do you know what to do it by? Well, look at your numbers, guys. My x value is a 12. Well, I can get to 12 pretty easily by counting by 2s. My y value is a 35. I don't want to count by 2s. That's an odd number, so I'm going to count by 5s. So just base it on what your x and y values are. Remember that this graph is in no way going into the computer. It's just going on your paper so that you can obtain the radius, which will enable you to obtain the correct equations. So remember, after we draw our graph, we start by plotting our center point, 0, 0. Got it. Then we're going to do our extra point, which is 1235. So 2, 4, 6, 8, 10, 12, up 35, 5, 10, 15, 20, 25, 30, 35. Okay, so for me it's about right there. So this point is 0, 0, and this point is 1235. So I'm going to draw a triangle. I'll always do my slanted line by connecting the 2 points, and then just drop it down and over. So I know that this bottom, the base is 12 units, and the height is 35 units, and I need to find the radius. So again, I'm going to use a squared plus b squared equals c squared. So that would be 12 squared plus 35 squared equals c squared. Now let me note that a and b are interchangeable, so it doesn't matter if you do this one is a and this one is b, or this one is b and this one is a. It doesn't matter. What's important is that the r is the c. Okay, the hypotenuse is the c. So you can do 12 squared plus 35 squared, or you can do 35 squared plus 12 squared. Either way. Okay, so 12 squared is 144. And 35 squared is 1,225. Okay, so 144 plus 1,235 is 1,369. And remember, these are R's. This is your R, your R, your R. So you square root both sides. So R equals 37. Okay? So now we're just going to do x squared plus y squared equals 37 squared, which means x squared plus y squared equals 1,369. Okay? And that will be your final answer. So that's 2 identical problems. This takes you all the way through 3-4. So thank you for your patience, and thank you for going through this and filling in your notes. I really appreciate it. I'm sorry that we had to have a cancellation day, but I'm really glad that we're able to come up with a solution so that I can explain things to you. I would rather you take the time to watch a video where I can thoroughly explain everything to you than you to have to try to figure it out on your own, or me to go through it quickly in class. So I appreciate you taking the time to do this. As you know, I'm always here to answer your questions, so just send me an email if you need anything.